Exercise 11.4, similar triangles. Two triangles are similar if their corresponding angles are congruent to one another and their corresponding sides are proportional. So looking at these two triangles here, the similarity statement right down here at the bottom is very, very important. First of all, that's the symbol that is read as is similar to. The order in which this similarity statement is given is very, very significant. It tells you which angles are congruent as well as which sides are proportional. Because this starts as triangle ABC, triangle DEF, that means angle A and angle D are congruent. The next letter that is given is triangle AB, triangle DE, so that means B and E are congruent. And finally, triangle ABC and triangle DEF, that means that C and F are congruent. Likewise, that means if we went to set up, because the corresponding sides are proportional, if we went to set up proportions, AB and DE would be proportional, side AC and side DF would be proportional, and side BC and EF would be proportional to one another. So the order in which the similarity statement is given to you is very important. That's going to tell you angles that are congruent and sides that are proportional. Triangles ABC and DEF are similar. Find X. Well, looking at our similarity statement, AB and DE are proportional. So that means that 5 over 10 is a true ratio. And finally, the side we're looking for is AC. That's AC, so that means that's going to be proportional to DF. So that is going to equal X over 12. Biggest thing when you're setting up your proportions here, make sure that you are going from one triangle to the other in both ratios. Do not switch the order in which you go. Cross multiply here, don't even really need to. We're getting X by itself, so simply multiply by 12 to get X all by itself. Take 12 times 5/10 in your calculator, and you should get X to be 6. Okay, second example. Right triangle PQR is similar to triangle STV. The hypotenuse of PQR is 12 units long, and one leg is 6 units long. Find the smallest angle in triangle STV. Okay, so let's first draw a picture of what's going on here. We know that PQR is a right triangle. The hypotenuse of PQR is 12 units long, so I know that that's 12. One of the legs is 6 units long, so let's call this bottom side 6 units long. Our second triangle, STV. STV. We want to find the smallest angle in triangle STV. Well, we know that these two triangles are similar. So in the top one here that's drawn in blue, we can find that third side right away by using Pythagorean Theorem. So let's go ahead and do that. If I use Pythagorean Theorem there, let's call this missing side X. X squared plus 6 squared equals 12 squared. Subtract the 36 over, you get 108. If we start breaking that down, root 108, same as 36 times 3. Square root of 36 is 6. So we get 6 root 3. There's our missing side. So now, using what we know about triangles, in this top triangle PQR, we have to ask the question, where is the smallest angle? Well, we know the smallest angle has to be across from the smallest side. 6 in this case is the smallest side in this triangle, which means that that angle P has to be the smallest angle. Likewise, the smallest angle in triangle STV has to be the one that corresponds with angle P. Triangle PQR, triangle STV, that means that angle S is going to be our smallest angle. We want to find the measure now of that angle. Well, remember, angle P and angle S are going to be equal, so let's go back up to this top triangle right here, and let's find that angle. The sine of angle P is going to equal the side opposite, which is 6, over the hypotenuse, which is 12. In your calculator, anytime you are finding an angle using the sine, cosine, or tangent, which is what we're doing in this case, that is when you have to hit your second function, sine key of 6 over 12. So now going to our calculator, I want to hit second function, the sine key, and I'm taking the inverse sine of 6 divided by 12. It equals, and there is our degree measure, 30 degrees. So that means we know that angle P is equal to 30 degrees. More than that, what we were asked for is to find the smallest angle in STV, so we know that angle S also has to be 30 degrees.